Welcome everyone to the Making Big Data Work in the Cloud webinar. I'm Mike Odenheimer, representing the Make Big Data Work Consortium, made up of 4 complementary big data companies which are represented today. Although you'll be in a listen-only mode, we encourage you to ask questions in the chat section. At the end of the webinar, I'll ask as many of your questions as I can. Lastly, slides from this presentation will be sent later this week. So without further ado, I want to introduce you to Matt Aslett from 451 Research, where he is Research Director for Data Platforms and Analytics. Matt is a regular speaker at several industry events and was named among the top 200 thought leaders in the field of big data and analytics. Along with Matt are 4 experts. Who are instrumental in making big data work in the cloud. We have Bertrand from Trifecta, who specializes in data wrangling, Bob from Waterline Data, specializing in big data catalog and analytics, Clark from StreamSets, who specializes in data ingestion, and Steve from Arcadia Data, who specializes in big data analytics. With our introductions complete, Matt, the floor is yours.
Thanks, Tanvi. We'll just swap the slides over
here. We go.
And we'll
there you go.
Tracking. Okay, so everybody should be able to see my screen now. So thank you everybody for joining us on today's webinar, and thank you to all the participants for having us on. So I'm going to kick off today talking about obviously big data in the cloud, some of the key trends that we're seeing in this space. Talk about some of the usage trends that we're seeing. Briefly, introduction for those who've not come across the organization before. So 451 Research is an IT research and advisory company focused on innovation in particular, but we cover that, the whole of the IT industry. Obviously, the area that I'm specifically focused on, though, is data platforms, data management, and analytics. Run the team here who cover our focus on that. So one last thing I'll just point to here. So we have 85,000 plus IT professionals, business users, and consumers in our research community. That's a growing area of 451 Research, and those people are, they're not individually customers of our research, but many of them work for companies that are. But what they are is practitioners, people out there in the field using technology as part of their daily, working lives, and obviously their home lives, and those two increasingly overlapping, and they help shape our view on the world by taking part in surveys and interviews, and you'll see some of the results of that as we go through some of the slides here. And in return for doing so, they do actually have then access to our research. If that's something that you might be interested in, you'll have our contact details, and they're always interested in adding new people to that community, especially around data and analytics. So if that's something that interests you, just let us know. But to get into the content itself, I think what we've seen, particularly the trends over the last few years, is increasingly the cloud is becoming we would say the default business environment, particularly for run the business kind of workloads. I mean, I think historically we've seen more sort of transient peripheral workloads being adopted in the cloud, but especially in the last few years, a lot of focus on data and analytics workloads, and the cloud becoming a core business environment. And there's a number of reasons for that. We'll get into the details on that, but at a high level, we definitely see sort of agility is one of those reasons, the ability for organizations to spin resources up and down as they're required. Also efficiency, obviously along with that comes some potential cost savings, not always guaranteed, but definitely in terms of upfront investments in physical data centers especially, but physical resources and server infrastructure as well. And the third reason I'd say is almost sort of specific to data and analytics is almost what we would call inevitability. Follow the data. I think as more and more data is stored and processed in the cloud, so we see more and more analytics workloads being drawn to the cloud. And we'll talk about that and some of the reasons for that as we go through the slides here. So the first thing was to talk about, the use of public cloud or infrastructure as a service functions. And as I said, historically we've been talking to end users about their plans in this area for many years. And we've always seen, of course, database and analytics are key workloads. So they've always been there or thereabouts in these surveys, but not actually. If we look back a couple of years ago, not towards the top at all. As I said, it was perhaps more sort of peripheral workloads that were being adopted in the cloud. But we now see in our surveys that actually half of the top functions used by organizations in public cloud are data related, and in particular I've highlighted here obviously data and business analytics towards the top with 42%, and actually machine learning, still early stages obviously for machine learning, but at 22% already as well. So a significant adoption of analytics workloads in public cloud infrastructure as a service environments. And if we look ahead, this is asking people what they intend to do in the next couple of years in terms of adoption of workloads. Perhaps no surprise, given a little bit of hype we're seeing at the moment. Machine learning, top of the list at 27%. But interestingly, even though it's already one of the most widely adopted workloads, data and business analytics coming in here, third place at 18%. So still a significant area for investment. And actually, as an aside, we ran a survey right at the start of this year, asking people about their top IT priorities for 2018. Actually, business and data analytics came out #1, ahead of things like machine learning and containers and blockchain and lots of other sort of more fashionable, shall we say, sort of trends. BI and data analytics, is still an area for investment because it's still an area that's evolving, new technologies and approaches being delivered all the time. And also, of course, it's an area where we're seeing a greater investment particularly in the cloud for BI and analytics for new workloads. And that is going to have a significant impact, especially, as far as our respondents tell us, in terms of the location in which data processing, analytics, and business intelligence is going to be performed over the next few years. So today, we look at this, 35%, by far the majority of data analytics and business intelligence workloads are being performed on-premises traditional resources and infrastructure. But just looking at 2 years, according to our respondents to these surveys, that's going to decline down to 8%, and we see a big swing towards both infrastructure as a service, rising from 12% to 27%, and software as a service and hosted applications rising from 11% to 22%. And this isn't necessarily, it should be said, these are respondents who are already sort of adopters of cloud. So obviously there's a lot of mainstream adoption which is going to remain on premises. But there is clearly a big swing happening, particularly in relation to organizations that are proactive and are already moving ahead on their cloud transformation journey. Why are they doing that? I already touched on some of the high-level reasons already, but this is what our survey respondents tell us, and this is across kind of all workloads in the cloud, not specifically data and analytics. But by far, the #1 reason is always reducing IT costs. As we said, not necessarily guaranteed. We've actually got a whole group of analysts here in 451 Research who focus specifically on cloud pricing and try to decipher how exactly you do get the to achieve cost reductions, because they're definitely not guaranteed. But the second reason, again, and we've seen this coming up anecdotally more and more as well. In fact, in many cases, even though cost is perhaps the #1 justifier for moving to the cloud, actually agility tends to be one of the core sort of business drivers. It's about being able to develop new applications and to deliver new initiatives more rapidly because you have enhanced IT systems agility. And somewhat related to that, and certainly in terms of the ability to deliver more rapid application development and new project deliverables, is I'd say look at the next 3 on this list here. They kind of go together. They overlap a little bit. Improved access to new technology and resources and capabilities and features, also deploying new applications and features faster. Of course, there's no reason why you can't do that on premises, But what we do see is that the adoption of public cloud enables organizations to move more rapidly and to deliver on those kind of opportunities. And the middle one there I skipped over is like modernizing IT infrastructure. Again, of course, you can do that on premises, but it takes a significant investment. Not that a lot of organizations aren't doing that, but for many, it's much easier to perhaps skip and adopt, in existing cloud services in order to take advantage of, modern IT infrastructure and new applications and new features functionality than it is to do their own on-premises, development. I was being very careful as we went through those examples not to talk about workloads moving to the cloud. Hopefully I managed that. It's not always easy. I think it's one of these things we kind of stumble into, is talking about workloads moving from on-premises to the cloud. We've actually tried to be very careful about this, because for the most part we see that most workloads aren't actually moving from on-premises to the cloud. This idea of sort of lifting and shifting applications from on-premises to the cloud, it certainly does happen. It's not to say it doesn't happen, but certainly this is some interesting, results from another of our surveys. This is asking specifically about, the strategic approach, particularly for mission-critical legacy applications. And what we see is that lift and shift, simply migrating existing applications from on-premises to the cloud, is amongst the minority there, just 12%. We see more people doing what we would call repurchase and shift. So perhaps keep the same applications, although probably a newer version, and adopt that in a SaaS or an off-premises hosted environment. Also, we talk about refactor and shift. So, again, perhaps the same application, or at least the same provider, but, a redesigned or a newer application, newer version of the application, which is taking advantage of more cloud-native frameworks and deploying off-premises. Of course, we can't ignore the fact that, the largest proportion of respondents here are actually keeping those applications on premises whilst also moving to modern applications and infrastructure architecture. So, and of course, some even just staying as they are. And so, another sort of key sort of message that we see from customers is there is a real mix in terms of what they're doing. Some workloads are being adapted more rapidly in the cloud for certain applications. Some, will remain on premises to the end of their current lifespan and are being replaced by newer versions, and some are obviously being repurchased and refactored and shifted to the cloud. So there's a lot of nuance here, and it isn't simply a case of workloads moving to the cloud. This is the same slide I presented before, talking about the workloads that are most popular in terms of cloud adoption. The reason I'm using it again is I wanted to highlight, I think it highlights one particular trend that we want to go into more detail on, which is the difference between data and analytics, business analytics workloads being adopted in the cloud, or workloads being used in the cloud, and data warehousing being used in the cloud. And this is something we've noticed over a number of years in our data, and obviously talking to enterprises as well. And it really illustrates this trend we've seen in relation to the separation of compute and storage. If you think about your data analytics and business intelligence workloads and your data warehouse, traditionally those were very much delivered as a combination, sometimes literally within the same physical infrastructure, or at least as a combined or tightly coupled grouping. What we've seen is that data and analytics and business intelligence workloads have been moving to the cloud. I'd say I did it myself there. All those workloads being adopted in the cloud much more quickly or rapidly than we see that data warehousing workloads are being adopted in the cloud. So something is going on here, and there's multiple reasons for that, but the key reason that in relation to what we're talking about here is this separation of compute and storage, and in particular the use of other cloud data platforms, in particular obviously cloud storage, as a platform for serving up data for analytics, and it's really about moving the data to the rather than moving the data to the compute, moving the compute to the data, analyze that data where it is if not generated, at least where it resides in terms of cloud storage. And this doesn't suit every use case. It's not happening. The data warehouse is certainly not going away anytime soon. But definitely, we see an increased number of organizations that are looking to take advantage of analyzing data in cloud storage. And there's a number of reasons why you would do that, which can be summed up in terms of cost, scalability, and durability. In terms of cost, we see that by separating the query engine from the data layer, companies are able to elastically scale each independently, which means you can then optimize in each independently for the lowest cost and highest performance, at least in theory. Additionally, again, in theory and often in practice, users then only pay for the compute resources they consume as and when they analyze their data, as opposed to having to scale for the maximum potential usage. Talking of scalability, as I said, scalability is the second reason. Of course, data warehouse environments increasingly scalable over the years. Hadoop itself, obviously inherently scalable, but particularly in relation to sort of, why why analyze data in cloud storage rather than spinning up, for example, your own Hadoop environment in a compute cloud environment. Well, Hadoop is scalable, but it requires local storage, and scaling HDFS in the cloud requires manual configuration and management of associated storage. In comparison, cloud storage environments, S3 for example, or others from Google and Azure, are designed automatically to scale as more data is added without any direct user involvement. So just from a sort of a configuration and management standpoint, much simpler to enable the data to accumulate there rather than having to continue to administer and configure a related Hadoop environment. And the third reason is durability. So if we take, again, let's take Amazon EC2 as an example, but the same is true across other clouds. Data is persisted in EC2 storage instances only for the life of the instance itself. So if something goes wrong, or for some reason you pull down that environment and then you look to bring it back up, obviously you have to deal with the ramifications of that. In comparison to, again, let's use S3 as an example, the data is always persisted in S3. And S3 is in fact designed to deliver durability of, it's 99 point, I'm pretty sure it's 9 nines, it might be 8, I'm not going to count them right now, but a huge number of nines of durability, to the extent that even if the most highly skilled Hadoop administrator looking to create their own environment in the cloud is not going to be able to match that. Similarly, with a relational data warehousing environment as well. And so as I said, it doesn't suit every use case, but certainly if you look at that combination of durability, scalability, and cost, and additionally, of course, if you're already using cloud storage as the initial place in which your data is stored from multiple applications, then increasingly we see that organizations are looking to bring their analytics capability to that data rather than extract the data from that environment to create a specific analytics environment. Moving on from there, so we've been talking about the cloud actually so far as almost as if it's one thing, although we mentioned there obviously there are multiple cloud offerings available. Increasingly what we see is that it's a multi-cloud world. A lot of organizations have, I'd say most organizations have multiple clouds. I think we saw in a survey last year that 60% of cloud adopters are using more than one of the major cloud providers. And what we found is a lot of organizations have actually kind of stumbled into that situation. They've had through shadow IT or, just through different projects, initiatives with different requirements. They've spun up different environments in different cloud, with different cloud providers. Even if, they're being more strategic about that, we call this sort of multi-cloud plus, where they are deliberately migrating workloads between those cloud environments, perhaps for HA reasons. Excuse me. even if they're doing that, it's not a really sort of strategic use of those multiple cloud providers. What we're seeing is increasingly companies are actually doing this deliberately, and the phrase hybrid cloud is used by different people for different reasons. When we talk about hybrid cloud at 451 Research, we're talking specifically about organizations deliberately using multiple cloud environments to support a single business function across those multiple cloud environments. And that is something that we actually added sort of to our service a couple of, I think it was last year, in response to, we saw that customers enough customers were doing this. It was actually worth adding on there. So it was in response from us. And as I said, increasingly that's something organizations are looking to do. And in fact, we asked specifically people in relation to data processing, analytics, and business intelligence functions if this was something they were looking to do in a survey earlier this year. As you can see, more than half said they were already doing it. Obviously these are people who are already using a cloud. 9% are planning to, 14% are considering it. So, the vast majority are actually looking deliberately to use multiple cloud providers. Why would they do that? Obviously, there are some inherent challenges in that. It's a potentially complex approach to take. The primary reason is in terms of improving performance and availability by using multiple cloud providers. Also, there is the potential to sort of optimize for cost. Again, perhaps easier said than done, but that potential is there, and that is certainly one of the aims that organizations have. Excuse me. And the third is about adding new functions to existing deployments. And this is something we see, and analytics is a good example. A good example of this would be a company, an existing analytics deployment application running in one cloud, but perhaps an emerging requirement to take advantage of, for example, some speech to text, machine learning capability or visual analysis machine learning capability, and may have a specific requirement which is fulfilled by a specific service, perhaps on a different cloud, and the ability to call out to that cloud, that service specific for that specific requirement, but delivering it as a seamless whole to the end user. Now, we talked then about this expanding sort of universe of your data and analytics landscape towards sort of what we would consider more of a globally distributed multi-location environment. And of course, that brings with it, as I said, some significant challenges. And it's something that a lot of organizations have been challenged with. It's a growing problem they've been challenged with for a while. You think about sort of historically, in theory, this idea of sort of a single enterprise with a single enterprise data warehouse at the heart of that enterprise. That was the theory. It never quite worked out that way. Obviously, organizations had multiple data marts, departmental data warehouses, and more recently, data lakes. And, data spread throughout the organization in different databases and data platforms. You add the cloud to that. In theory, as I said, it would be another layer. In fact, it ends up being at least, 2, maybe perhaps 3 different layers of multiple clouds, multiple databases, and increasingly difficult for organizations to identify what data they have as a whole, across that estate. And, having to manage multiple databases as well. Add on data processing at the edge, and that's, perhaps an emerging requirement for a lot of organizations, but it's only going to make this more challenging. So the question is, how do you begin to deal with that and get that under control? Well, certainly one of the ways is sort of standardization, and we definitely see a lot of organizations obviously looking to consolidate in terms of the number of database and data platform providers that they're dealing with. It's not necessarily ideal actually to get that down to one, or in some cases, there are unique data processing requirements for particular applications, and especially as you go out to the edge. So it's not necessarily the case you can get down to one provider, but certainly, it's an achievable goal to reduce the number of providers that you have. The other side of that is, obviously, we've seen that the growth in the last few years in this concept of the data catalog in terms of being able to index what data you have initially, perhaps in a Hadoop environment, but then expanded that to your relational databases and out to cloud as well, and both in terms of Hadoop and database workloads in the cloud, but also cloud storage. So at least giving organizations that ability to understand in an easier manner what data they have and where it resides across that data estate. And I think it's this combination of the data catalog and potentially some standardization, which gives organizations the much greater potential to bring this challenge under control. And another way to look at this, if you think about initially sort of this idea of the data lake was in theory kind of a simple environment for ingesting data from multiple applications on the right hand side here, and then making it available to multiple users for multiple purposes, be they senior executives or business analysts or data analysts or data scientists. And of course, you would actually have multiple groups of these in multiple departments. We've seen that in reality, data continues to be spread, of course, across multiple locations in the database and in the cloud, and as we've said, and of course, in multiple clouds. So, in order to make this idea of this data lake a reality, what we see is, data cataloging and data governance is required to know what data is in those, that environment or those environments, as well as providing capabilities for things like data lineage and data security and access rights, and still very much a role for IT and data stewards to take care of those kind of capabilities, while at the same time, acting as an enabler for self-service, particularly self-service data preparation and also potentially self-service analytics, in terms of giving end users the ability to do things like data cleansing and data discovery and data enrichment, and particularly to collaborate both amongst themselves and also with data stewards as well. I think we see that data collaboration is an increasingly important part of this sort of modern approach to data management, and enabling that collaboration between IT and the various sort of business users. Beyond that as well, of course, we're not just talking about historical data that is static and resides in databases and Hadoop in the cloud. We are talking about the ability to constantly update that data and move data between those environments if needs be, using stream processing and real-time integration capabilities. And also we see a continual or emerging increasing role for what we might consider a scale-out analytics acceleration layer, because there are still multiple use cases for analytics. There's multiple approaches to analytics. There's multiple requirements to analytics from those various data sources, and so there's a sort of analytics acceleration layer to deliver the performance required to serve up that data for multiple users, as well as also potentially querying that data as it is streamed into that environment as well. So again, it's not just about the sort of static historical data, but also potentially that data in motion as it flows throughout the organization. So that was obviously a bit of a brief run through of some key trends that we see, just to cover off some of the key takeaways that we see from our perspective. As I said, we do see the cloud is becoming the default business environment for new analytics workloads, particular as more data is produced and stored in the cloud, driven by benefits including agility, efficiency, and modernization. The impact of that is, it appears to be, a potentially considerable shift in the coming years in the primary environment used for data processing, analytics, and business intelligence. From certainly in terms of our respondents show us, a big shift from 35% traditional on-premises and 12% public cloud today to 8% traditional on-premises and 27% public cloud today. Obviously, as I said, those are sort of already cloud adopters, so the impact in terms of more mainstream conservative enterprises is going to be slower or perhaps delayed, but there is a significant shift that is happening. And thirdly, of course, the future is hybrid. We're not just talking about on-premises, we're talking about on-premises and cloud, and not just cloud, but multiple clouds, and not just Hadoop and relational databases, but cloud storage as well. And so analytics users and vendors need to prepare if they haven't already, for future of multi-venue analytics deployments with workloads spread across on-premises non-cloud, on-premises private cloud, infrastructure as a service, software as a service, hosted private cloud, hosted non-cloud, as I said, in relational databases, in Hadoop and cloud storage and many more platforms to come. And as we said, the way in which we see the organizations are able to do that and able to sort of get a handle on the capabilities or the potential capabilities that they can deliver here is through the data catalog as a primary function for that. But also, we talked about self-service data preparation as an enabler for insight, streaming integration to cope with, handle data as it flows throughout the organization, and also analytics acceleration to drive the performance required for what continue to be different use cases with different performance requirements. So with that, I will thank you very much for your time. I'll remind you that we're going to have some questions and answers later. So if you've got any questions on what I presented or as we go through here, then please continue to submit those. And but for now, I will hand you back to Tanvi to take you through the rest of the presentation. Thank you.
Great stuff. Thanks, Matt. And this is Clark Patterson from StreamSets. So let's just transition over to the next part of the content here that just kind of talks about how the vendors supporting the webinar today are helping enable and solve a lot of the trends that Matt highlighted. While we're waiting for the slides to come up, will remind everybody that, as Matt alluded to, we are going to take questions at the end. So by all means, please enter your questions into the chat panel, and we will triage those once we get down to the end of the content. So what we want to chat now is, thinking about all the trends that Matt just took us through. How do we actually start to put together an architecture to make all this happen, and ultimately insulate ourselves from what, quite frankly, is a lot of change that we saw there, or we can expect, pardon me, from the observations that Matt shared with us. So each of us vendors are going to talk through all the core components that go from data curation and ingestion all the way at the far left to actually getting into self-service BI and visualization on the far right, and everything in between, and really talk about how we enable these types of things. So if you go forward one slide. We heard quite clearly that there's a massive shift going on to the cloud. So across the leading three providers, but it also on-prem, there's definitely an upswell of adoption of different technologies that span both cloud and on-prem. And if you're not already thinking about it, the main takeaway you should have from our discussion here is that it's probably going to be a requirement in the near future, and hopefully Matt has shared some helpful advice to get you going down that path. The first thing that I would like to talk about, next slide please, is if we've already bought into this idea that, can you guys advance the slides? Thank you. Yeah, that the cloud is for you. How on earth do you actually just get data in there, right? And so that's the idea of data ingestion that the StreamSets focuses on. So if you go one more slide, we've observed that cloud is indeed a trend, and I've borrowed from some research from Matt and team from September of last year, which, as you can see here, by 2019, 60% of all workloads will run in the cloud, and we observe that exact thing here at StreamSets. About half, or more than half, of our customers today are leveraging cloud in some capacity. And so it's prudent on us to ensure that all the various workloads can be supported across a hybrid mesh of different technologies, both on and off the cloud. So next slide. Our core premise is that unless you're insulating yourselves from change, you're ultimately going to struggle from broader adoption of cloud services. And there's three pillars in which we actually talk about the change and how it could hinder. We term this thing drift, or data drift. But really, there's, if you kind of step back and think about it, the architecture, or the storage and compute, as Matt outlined, what you use today is probably not going to be what you're going to need and or use tomorrow. That's going to morph in some capacity. It could be that new technologies come along that you want to adopt. It could be that you already have a roadmap for your architecture where you're going to insert things into your architecture. Or it could be the technologies themselves ultimately change, and arguably they change a whole lot more rapidly than what we're used to. And when you think about the fact that your architecture spans on-prem and there's stuff in the data center that you can control, there's a bunch of stuff in the cloud that's coming at you at speed. It's really important that you can insulate from drift on the technology side of things. Otherwise, you're going to spend more time trying to reconcile all the changes of the technology itself and less time actually innovating and getting downstream to that self-service BI and visualization. The second aspect of drift is all about the structure and the semantics of the data itself. So it was interesting to see the difference between the two slides that Matt showed of, what are you using cloud for today versus what are you planning to use it for tomorrow. And in particular, that was that big shift in machine learning. In all likelihood, behind that, the data that's going to support those workloads also is going to change. So the assumptions that we make, again, about the data requirements that our analysts and data scientists have today are not going to be what they have tomorrow, right? So we need to be able to ensure that as new data sets come along, as changes in both the structure and the semantics of the data that we are using come along, that change itself doesn't become an Achilles heel to what you're trying to ultimately accomplish. And the third thing is this idea of requirements or just the pace of delivery of data, if you want to simplify it down to that. But increasingly, and this is a testament to both cloud but non-cloud, as more people become data consumers and more people become data analysts, the requirements for data delivery are going to become highly variable. So, batch was a thing, batch remains a thing, but increasingly people want data in real time. If you kind of pull back the layers and you dig into real time defined differently across different stakeholders. And so you need to be able to mix and match a whole set of delivery patterns to support an increasing set of needs to a broad range of consumers. So on the next slide, just quickly, the StreamSets platform, we call this a data operations platform, is built to help stitch all of the data systems together to support workloads and moving data across your business, regardless of the technology you use, the data that you're using and whether it changes, and the latency requirements that you have for your various stakeholders. So we break the problem down into building pipelines, executing them seamlessly across cloud and on-prem, operationalizing them so you have full confidence in data movement at any point in time, and where sensitive data is involved, protecting that information so you're not exposing yourself to any harmful circumstances, be it regulatory compliance or otherwise. So that I'll pass it over to Bob, who's going to chat with us next about the role of the data catalog in the flow. Bob?
Great, thanks, Clark. So let's go ahead and go to the next slide. Yeah, so what I'm going to talk with you today about is the Waterline data catalog, and let's go ahead and advance to the next slide as well. Many of the big data projects that we're talking about are still struggling to meet expectations today, and the traditional data warehousing best practices that we use for managing data, finding the data, securing the data, they're just not working in this new, less structured petabyte world of big data. And so that's what I want to talk to you a little bit about, the role of a catalog in helping you address that. There's challenges you have to face, like data lakes often turn into, we all have heard the term data swamps, where business analysts and the data scientists really spend the majority of their time trying to find the data rather than analyze and understand the data. That's a significant challenge that has to be overcome. And at the same time, data regulations continue to increase. We've got GDPR, we've got new regulations coming out of California, and regulations and data security has become more important, and companies are struggling to identify the sensitive data in their data lakes and figuring out how to lock that down easily. So one of the core issues that drives a lot of this is that, potentially you have billions of fields. We have two customers I can think of. One customer has 4.1 billion fields as their estimate. Another has 2 billion. There's just a lot of data, right, that oftentimes is labeled or tagged with obscure, missing, or inconsistent metadata, right? So trying to understand your data when it's not well labeled or tagged is really difficult, right? It makes it unsearchable, undiscoverable, and difficult to secure. And that's why, as Matt described, an enterprise data catalog has become a necessity in successful big data deployments. To address the challenges that I just talked about, the data catalog must be able to automatically determine the contents of your data and tag that data with understandable, easily searchable business terms. And it's got to do that with a high degree of accuracy, and it's got to do that at petabyte scale. So, you know, that's a tall order. And really the only way that can happen in this new world is through an AI-driven enterprise data catalog. And that's exactly what Waterline data catalog is and does. It automatically inspects and accurately tags your data with business terms. And it does this in 3 phases. So the first phase is Waterline inventories all of your enterprise data, and it does that across, you know, cloud, on-premise, and relational. You know, Matt talked a lot about how, you know, multi-cloud is a reality, and I think over 60% of the companies that they surveyed, you've got your traditional relational databases. So you've got across your enterprise data state, you've got hybrid environments, and you need to be able to work across all of those. Waterline does that, and it does it at petabyte scale. And that's because we were built from day one to run in a big data architecture, and we take advantage of scalable compute platforms such as Apache Spark. So that's kind of the first stage, is inventorying and profiling the data. The next stage is how do you then start to understand the data, what the business contents of that data are, and tag it appropriately. And we have an AI-driven engine called Aristotle that does exactly that. It examines the values of the data and then will determine, as it learns by watching, you know, business users and has learned from existing metadata you may have, what data looks like. So it can look at a list of company names and correctly label, is this a set of customers or is this a set of suppliers, based on the AI engine that's learned what your business looks like. So that's the next stage, and it does that in collaboration with your users and crowdsourced curation and information. And it also allows your users to easily collaborate with each other through ratings of data or comments that they may have about data. And then the final piece is, of course, how do you consume that data, right? And we're talking a lot about that. You know, you have trifecta for self data prep, you have Arcadia. So self-service analytics is a big category for most of our clients who are using a data catalog to inventory their data and tag their data automatically. We then pass that over to trifecta or an Arcadia for the actual self-service analytics. But what we do is we actually allow your business analysts to find the data, so that they're not spending a lot of time going around and trying to question everybody about where the data is. We've tagged that data automatically. They can easily search for it, find it, and see comments from their peers about that data and understand that it's fit for purpose. We also do allow for organizations to secure the sensitive data that they have across their enterprise and across their data estate. So we'll allow them to say, so you may have a governance team that says, I want to lock down all of the data that contains ethnicity data, because that's sensitive data. What we allow them to do is just say, you know, lock down ethnicity, and then we understand where the 200 versions of ethnicity are across their enterprise and can help make sure that it gets locked down appropriately with the infrastructure for security and access control that you already have. And finally, migration, IT teams need to manage the data lakes to prevent them from becoming data swamps, where data clutter makes it difficult to analyze and govern the data. Waterline can identify the overlapping and replicated data across your data lake or across any of your platforms, so that you can easily then merge or delete or you know, make sure that you're not getting too much clutter within your data lake. And this is not only at after you've loaded the data, this is extremely useful when you're migrating your data into the cloud to make sure you don't load too much duplicate data. So that's a high-level overview of Waterline Data Catalog. It easily integrates with enterprise software that you already have. And one of the most common products that we typically integrate with, a lot of our customers are using Trifecta alongside of us. So with that, I want to turn it over to Bertrand. Bertrand is the Senior Director of Partners and Solutions at Trifecta. So Bertrand, why don't you tell us a little bit more?
Thank you, Bob. Yeah, you're right. After data has been ingested into the lake, cataloged thanks to Waterline, data can be available for the business users, the analysts, the data scientists, through the inventory of data, through an assessment of the data and the quality of data. So the next step is really about wrangling that data into a format that can be consumable for analytics like BI, like Arcadia data, or for machine learning. However, like Kaggle founder and CEO Anthony Goldblum like to say, 80% of data science is cleaning the data and 20% is complaining about cleaning the data. So it's not because, so data has been assessed, identified, but it could still be duplicated. It could be different standards in the data lake. So how can a business user, an analyst, someone who is not a specialist in any like technology, would be able to combine, export that data and make it available for consumption. So if you move to the next slide, so really the data preparation is in between this data platform layer and the business layer. And the way Trifecta is working and why we can have like business users to clean, structure, combine data set is because with Trifecta, we really shift the around the, that problem. Like typically a user would create some SQL statement or would run some code on top of the data, analyze the result, do some like statistics on the data, and based on that information, define rules to clean and structure and combine data set together, then rerun this type of code, and again, iterate on this. So with Trifecta, in fact, we're using machine learning to assess the data, understand the structure of the data, and highlight already for the end user data issues like missing values, like invalid formats, like outliers, like an age of 250 years for a person that should not exist. So Trifecta would identify these data issues, point them to the end user, and even suggest the type of transformation the user should do on top of the data to clean the data. And the user, with these suggestions, can clean the data, structure, and even join data set together up to the point that the user is happy with the final results he wants. So then it can apply these rules. We call them recipes. So all the work the user is doing in cleaning and structuring the data is recorded into a recipe that runs on whatever the data platform you are in the cloud. And then the result is exposed for BI, like Arcadia, or other machine learning technology for the user. So if you move to next slide. Yeah, thank you. So Trifecta, if you select Trifecta, you're ready. You are in on-prem, you're already in the cloud, Amazon, Microsoft Azure, or even Google Cloud Platform, because Google Cloud Data Prep is Trifecta. You can use our technology in your own private cloud or even public cloud like Google Cloud. And then also Trifecta has its own SaaS product in the cloud. So you can select whatever, I would say, infrastructure you have in the cloud on-prem. Trifecta will help you. And we leverage, of course, the underlying layer of Waterline to identify the data and expose it. And then we deliver the data to Arcadia. And I hand it over maybe to Steve from Arcadia that can talk about the next layer.
Thank you, Bertrand. Go to the next slide, please. So the last mile of making big data work in the cloud is self-service analytics. You can go ahead and advance. As Matt talked about, next slide, please. We want to bring the processing to the data. That was really the promise of Hadoop and cloud platforms from the early days, and Arcadia is focused on doing that. We view it as the market's shifting to what I would call a data lake type of architecture, which scale out MPP systems. And for the analytics part of it, people are choosing a new BI standard for that scale out environment, whether you call it a data lake or something else. One example of this from some of our customers is Newstar, where they have a software as a service application they've built completely in the cloud. They're using Arcadia as the front end for that. We distribute the processing within the cluster. They're supporting large organizations like AT&T with 8,000 users and 200 concurrent workloads at any given time. So it's that type of scale and that last mile of analytics we want to be able to deliver on these cloud platforms. If you go to the next slide, the way we do that is to really distribute the processing where the data sits. So I won't go through this slide in detail, but essentially we took the concept of an analytics or a BI server, we push it down to the individual data nodes that can rest within your cloud environments, whether it's Amazon, Microsoft, et cetera. Of course, you want to be able to connect to other data sources to bring that unified view across different types of data, as well as Matt talked to, being able to visualize data as it's coming in on the wire from streaming systems like Kafka, et cetera. So the idea is keep the data where it rests, analyze it there, and provide unified security and high concurrent analytics to a large number of users through a visual drag and drop type of environment. If you go to the last slide then, essentially what Arcadia does then is provide that Tableau-like experience on a very large scale for these cloud-based systems without moving data out to a separate tier. So it's all completely web browser-based, can fit into mobile, iPhones, those types of things, tablets, and really unlock the value that's in these cloud-based data lakes, if you will, for large numbers of users, while also reducing the burden on IT to administer that. And we do things as well from an AI perspective in terms of recommending the best visualization type based on the data, the cardinality of that data, and the dimensions underneath of it. So it's about how do we consumerize big data analytics on the cloud and anywhere else to a large number of users. So that's really what Arcadia does as part of this partnership. Back to you, Mike.
Thank you. I know we're running a little bit late, but we have time for 3 questions here. From Eric, some companies have struggled to get data lake deployments beyond the experimental stage. Why is it that why is that? And what are the best practices to avoid getting stuck in the experimental stage? Matt, you want to try that?
Yeah, no, I mean, I think that is certainly true. Some companies have certainly struggled. I think, part of the reason for that is a lot of companies started off, trying to prove out the underlying technology. Obviously, it was, the Hadoop and Spark, etc., was new, and they were trying to figure out what they could use it for. And I think we've seen some companies kind of forgotten about the business reasons, and ultimately it's the business reasons that will drive the expansion of any platform from sort of tactical to strategic, and from experimental to operational. So I think that's part of it. And the other part, I'm not just saying this because of my fellow presenters here, but I think what was really interesting is to see how the combination of capabilities that they deliver drives a fully functional, data lake or data processing platform, and that's something I think a lot of companies perhaps have focused on one aspect of that. The requirement has been driven by one aspect, and there is this need to look at the bigger picture and the broader strategic requirements.
Samir is asking, why not just adopt the services of your cloud provider and get it all from one place? Matt, you want to try that?
Yeah, I mean, certainly increasingly, the individual cloud providers have capabilities that overlap with some of the functionality we've heard about here. I would argue that no individual cloud provider could provide the complete picture that obviously the 4 vendors have talked about here. And also the point is, then you can only get that from one cloud provider. Certainly they don't offer any of that in terms of on-premises. And as we talked about, it's increasingly a hybrid world. So you're talking about managing data on-premises and in multiple clouds. And so therefore, as we said, end users we talk about end users looking for a bridge to the cloud. They're looking for a consistent experience with the data and analytics products they're using on premises, and potentially using the same service, those same products in multiple cloud across multiple cloud providers as well. So for individual use cases, it might make sense to just look at your chosen cloud provider. But as we said, most people have more than one chosen cloud provider anyway.
Okay, we just got 2 more questions. B Dash is asking Bertrand a question. Can trifecta profile data from unstructured data sources such as email and network file systems like SharePoint?
Yeah, good question. So as soon as the data is in text format, in some ways, could be unstructured in terms of formatting, like hierarchical data or JSON or XML. But when there is like some text, we can profile it. So most of the time, we use other technology that would convert email into something that is more textual. And then same for file system, we do a lot of logs and web logs and IoT type of files, but it has to be some way text. Like if you're asking me, can I access a PowerPoint? I will say no, it has to be converted into something that is more textual. Maybe we can also ask the question to Waterline, because Waterline has also some very strong profiling capabilities that we leverage within Trifecta. So if Waterline can profile that, then we can. So maybe a question to Bob as well. I don't know what type of data you can profile, like email or SharePoint.
Yeah, we can profile it somewhat, but not to the degree that you're talking about as far as keywording all of the data in unstructured data.
All right, a couple other quick questions, and let's see if we can answer these really quickly. How does stream sets and trifecta work together?
I can take that one. This is Clark. So I think if you just kind of think about what the core competency of our products are, the distinction should be fairly simple. So stream sets is all about ingestion and stitching together in an operational manner multiple systems stretched across an architecture. Bertrand can articulate it better than I can, but it's all about the wrangling exercise once you have your arms around that data. Do we both provide kind of ingest type capabilities? Yes, but I think when you kind of look at the products more specifically, we solve different problems.
Yeah, we are very complementary also in the way when so Trifecta is mostly used by business users that will look at data, exploring data that is in that data lake and define rules that can be operationalized. And sometimes it's useful to have then these rules operationalized with StreamSet that can take the specification of Trifecta. If StreamSet is part of a software development lifecycle between dev, test, production, Trifecta is used as a specification tool to implement the rules in StreamSet as well, to operation within IT group. All
right, last question, and then we'll wrap it up. And I don't know who's going to answer it out of the group, but are you Wan Chung is asking, are you suggesting we deploy all 4 products presented today? Who wants to handle that one?
Absolutely.
Yeah, in fact, this is Bertrand again from Trifecta. In fact, why we have a consortium of our 4 companies is because we've seen again and again customers adopting our 4 technology initially independently, and all of a sudden we discover that we were the best of breed of each of the requirement, the domain that can be streaming the data into the lake, cataloging the data, preparing the data, and then reporting on top of the data. And so it's why we created that consortium to share the good best practices.
All right, that's it. Thank you, Matt, and our experts. I also want to thank the audience for attending this webinar. Everybody stayed on. We'll send out the slides and recording of this webinar in the very near future. That'll be this week. Make Big Data Work holds new informational webinars on a quarterly basis. Please check our website for additional webinars. Again, thanks for attending and have a great day.
Thanks, everyone.
Thank you, everyone. Bye.